In this video, we are going to talk about the source transformation theorem, which we use to solve the source transformation equations in the electrical circuits. So, source transformation is the process of replacing a voltage source in series with the resistor by a current source in parallel with the resistor. Let's take an example. Just time to solve this. This is a voltage source Vs and is a resistance series with this. So we can change this to a current source Is and a resistor connected parallel with this R. So we can make this to this and this to this. That's it. The current source, the arrow of the mark is always point to be the positive point. We can change this to this to this. So when we use the source transformation, we easily solve the electrical circuit. So we have an example. We can easily understand what is the process. So this is the electrical circuit. So this is 6 volt voltage source, 2 ohms, 4 ohms. This is 0.25 Vx is the dependent current source. It's 18 volt independent voltage source, and here is a 2 ohm. This 2 ohm resistor has a voltage drop of Vx. So the question is find Vx using source transformation. So what we gonna do? We know that what is source transformation? A current source and a series resistor is being by a voltage source and a resistor series with this being by a current source and a resistor parallel with this. At the same time, this is being like this, so we're gonna make it this. So what we gonna, our first step, in here is a voltage source and is a resistor. What we gonna do? We gonna current source and a 2 ohm here, like this, here to here. Just we changed these two 2 ohm, and again there is a 2 ohm there, and it has plus minus Vx. And here look at this. This is a current source and is parallel with the resistor. So what we gonna do? Current source parallel with the resistor, we just change into voltage source. So the arrow is here, so I put positive here. So V is equal to IR. So this is I, this is R. So V is equal to 4 into 0.25 Vx is Vx. And here, oh sorry, I need to put the resistor here. This is 4 ohms and 18 volts. That's it. So what we gonna do? Here we need to put the current value. That's 6 volt 2 amps. So V is equal to IR. So the I is equal to V by R, 3 amps. So what we gonna do? We need to change again. There is a 2 ohm 2 ohm. So it become 1 ohm. 2 ohm 2 ohm parallel. So it's become 1 ohm. Just we change this. We gonna change this. This is 1 ohm because 2 ohm 2 ohm. It's have Vx in between here. So again we have a current source and parallel with a resistor. So what we gonna do? We again change this into voltage source and a series with the resistor. So 3 amps 1 ohm, so 3 volts 1 ohm here. So again it's have a Vx. So in here it's also Vx, a 4 ohm, an 18 volt. That's it. So it's a linear circuit, very easy. We can find from here. Just thought it was I current passing through this. So I'm gonna write the equation. So I'm gonna write the KVL over this mesh. So KVL to mesh. What is the answer? I'm starting from this. So minus 3 volts plus 1 into I plus Vx plus 4I my plus 18 is equal to 0. So when we solve this, 15 is equal to 15I, so minus 5I, 15 is equal to minus 5I minus Vx. So we need to, again, what is we need to find the Vx. So we need to find the Vx from here to here, V1 minus V2. So V1 minus V2 is equal to Vx. So that's equal to 3 minus I. 3 minus I. So we need to put the Vx value in here. When we plug this one, so when we plug these, we came to a conclusion that I is equal to minus 18 by 4 ampere. So I is equal to minus 4.5 ampere. So Vx is equal to 3 minus 4.5 ampere minus 1.5 volts. So Vx value is minus 1.5 volts. Very easy when we use source transformation to solve the equations. Thank you.